Okay, nice. So now we get a nice picture. As you remember how I arrived at my DPI, those configuration numbers, I am actually getting a pretty nice, decent view of the chart that is supposed to occupy as big as my screen. So it's containable within my screen. But because my console is a little bit small, so it's looking a bit largish. Nevertheless, you can always get a good view of all the history of all charts that you have produced in this lifespan of the console, all here, and the thumbnail of each image is shown on the right side. As I said, if you don't like this squeezy nature, always undock it and you'll be able to see more clearly. All right. So showing inline is nice, it's big, but not very helpful here. Um, and therefore we would default to looking at the pane, the chart pane or the plot pane. So over here we set title, okay, and everything is nice. Next, we would like to perform df. Did we just do that? Yeah. Okay. So we did that. We did the d dot plot dot py, and we can now look at the trend, right? So let's look at the trend. We just plot the trend lines, all right, and then plot area without capturing the AX. This time round, we discarded the AX that was returned because we are not interested to set title and so on. So it's not a mandatory thing that you store all the time. So it's running very fast. It's scroll past. We know that the first two charts we created by running it twice. So this is all storing all the historical charts that we have produced. Okay. Next, let's look at the trend and the area. So the trends part is actually drawn by this guy here. So remember when we say df.plot, the default is line. The default is also showing all the columns as input data and then sort of overlay one on top of the other. So sometimes we need this, sometimes not. And what if we only need B and D? Very simple. You just create you can always do df.loc, LOC, select all the rows and columns will be just a list of B and D. So because that is creating a new data frame on the fly, it is not changing df. It is not deleting all others. So you can always do a .loc .plot by plotting only selected lines and columns. And of course, we have the .area, which is basically a stacked graph with all the intermediate spaces filled with colors. The colors are, as we mentioned earlier on in the slides classroom, they are all automatically, brilliantly, and attractively automatically chosen by Matplotlib. So in most cases, whether we are doing some sort of a scientific systematic understanding of the data, or else we are trying to print out for a little bit of attractiveness in our presentation or impressiveness in our discussion with superiors and bosses, the colors are usually quite attractive enough for us to just use it as it is without much configuration or reconfiguration. So these deal with um, typically time series because we go from left to right, progressing in time. All right, we also can go by various progression. Maybe you go by age, maybe go by distance away from the city. So everything that is kind of having some sort of a progression, orderliness can be done by charts like these. Then we have a new figure, and on top of this, we try to plot these three charts first. Okay, so let's run this again. Now, things will start to pile on, and just bear with me a bit more by having more and more charts here, right? So we run, and blah 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 blah. Everything will be rerun and regenerated again. Okay, so here, um, the pie chart is starting all over again, right? So we have pie chart, then the trend chart, and then the area chart, and this is the new kid on the block here, the bar, right? So again, by default, all the columns are used, all the columns that can be interpreted will be used. So since all our columns are numerical, so they're all used. So in this case, we get to see all four columns values being put side by side in that order, A, B, C, D, right? So, and nicely colored, and we can compare. This could be season number 1. We have four different branches of profit performances, right? Season number 2, right, or first quarter comparison with second quarter, quarter by quarter comparison, branch by branch comparison, and so on. So this could be very powerful summary of multi-layered kind of that means there is structure within the measurement. So there's timeline, but there's quarter, right? And then there's within the quarter there are multiple branches which are also generating the profit numbers. So this might be a good way to summarize all this. And next we have the horizontal way to present. We talked about how depending on whether you're printing the chart with more horizontal space or vertical space, one of them could be a better choice. And also there's a need to be aware that people tend not to be able to contrast the horizontal lines in the same way as vertical lines like these, right? Because everyone, regardless of you being left or right-handed, left or right biased, will tend to be grounded at ground zero here, right? But here, there can be some sort of encouragement for either left-handedness or right-handedness people to look at things differently. All right, I'm not saying better, worse, or what, but they might end up having different interpretations, even though what you're trying to show is not based on right-handedness, isn't it? So you're creating different impressions about your chart unnecessarily based on different audience, and so that is not a desired goal, right? So be very mindful of what we are presenting. And the related chart is the box plot. Very, very useful, right? So in stock market, stock price comparisons, performance of exam by 4 different classes, performance of students taught by 4 different instructors, performance of sales force led by 4 different sales managers, a lot of usage of box plots, okay, because it tells a lot of stories, the main properties of the distribution. So excellent chart to summarize this kind of situation. Now, I did say that as we repeat more and more, our catalog of thumbnails grow, isn't it? So it's like 2, then 2 plus 4, then 2 plus 4 plus 6, and keeps growing unnecessarily. So here is, if we want to delete one chart, then we click on this one. Or if we want to delete the area chart, then we click the 1x. And triple X, what does that mean to you? Well, remove all. That's right. So XXX, so we remove everything, and we get back a clean library of charts, and then we can run again with new commands. All right. So I'm going to just quickly add another bunch of scatter plots, hex bin, density, and histogram. Okay, so let's do that. So all the charts will be generated again, starting from pi, then line, then area, and so on. So we just need to look at the new ones, the scatter plot of B versus C. Okay, so this is scatter plot. Very, very useful. And we can change the dot size, right, using various parameters. Read up the pandas documentation on dfplot. And there are commands that when pandas dfplot doesn't understand, it will pass down, like I said, down because it interacts with the matplotlib's pyplot. It will pass down to pyplot. For example, the control of the sizes. If you check out pandas dfplot documentation, you may not see how to control those. So to go down there, you need to also read up matplotlib's pyplot documentation on the more fine-grained control. For example, the dot size, and we learned about color, right? That's also a property that is going to be inherited by pyplot to determine what color to show. Yeah. So read up those for a bit of extra capability to adjust and control your charts. Okay. Next is the hex bin. I personally don't really use it that much, but certainly a great way to summarize areas of intensities like this. So hexbin, scatterplot does most of the job. I tend to personally, okay, want to see the cloud of points rather than being summarized by a hexagon. Uh, um, but it's a feature available. And then we have the densities, the continuous densities. So notice that even though our data frame, ABCD, contain all the integers, and even if you plot the histogram, it's very, uh, very clunky kind of bars, one can use KDE, right, the density chart, to sort of smoothen it and show a sort of equivalent statistical distribution if we infer from this histogram. So this is, but if you don't want to get to that level of details and mathematics, just simply use it as an approximation to a very very clunky histogram, and we don't want to show that. We want to show some smoothness. Then just use KDE. Okay. Next is histogram. So when I overlay the histogram of A on top of B, on top of C, on top of D, um, if I don't use transparency, the transparency, meaning that I allow some sort of the bottom histogram colors to show up. If I don't use that, then it's very hard to read, right? But when we use the KD, then it is quite okay because we don't have the colors in the areas here to create a confusion. But with a lot of the bars being colored, then when we overlay, we need a bit of transparency, or in this case, translucency, to see through. And when we see through areas of A and C, for example, when they overlap, we'll get a different color to indicate the sort of position and extent of overlapping. So this is nice to do that. Um, this chart, this overlaid histogram of A, B, and C, D may not look very attractive, mainly because our data frame is very uh, uh, small, and so the bars are not that high. The sort of spread of the values not that many. So end up it looks like this. So it is correct, accurate, but not very nice. But when we get more data, it should look prettier than this, because you then see a bit like a shaded version of this, like bluish here, greenish here. So you see areas overlapping kind of nicely. All right, so it's actually the same version.